Hello everyone, today we're talking about trig function of right angles, section 6.2 in our book. So first they want us to find the exact values of the 6 trigonometric ratios. So those are just the sine, cosine, tangent, cosecant, secant, and cotangent. They want you to find all 6 of those from the given information. So in order to do that, we're obviously going to need to know all 3 sides. We're going to need to know our adjacent, opposite, and hypotenuse. So to find the hypotenuse, just do Pythagorean theorem. And if I do the Pythagorean theorem, I'm going to see that I get a hypotenuse of length 17. I'm not going to do it for us. We should know Pythagorean theorem by now. So I found my hypotenuse length of 17. Then I just need to find all 6 functions. The first one I'm going to start with is sine. So sine of theta. We don't know what theta is, but we don't care. We just want to find the 6 trig functions with the given angle. So we're not worried about what the angle actually equals. We're just going to find all 6 ratios. So sine of theta is opposite over hypotenuse. So that's going to give us 15 over 17. Cosine of theta is adjacent over hypotenuse. So that's 8 over 17. Tangent of theta is opposite over adjacent, TOA, opposite over adjacent, 15 over 8. And then we got to do the inverse trig functions as well. So, or the, I should say the opposite trig function. So we're going to have cosecant theta, that's opposite sine, and that's just 17 over 15. Right? We're just going to flip sine over. Same thing with secant. We're going to flip cosine over. And same thing with cotangent. We just flip the tangent over. So those are 6 trigonometric ratios of whatever that angle may be. Next, we got to find the side labeled x. And we're not dealing with 13 or 14, so we're just going to do it to 2 decimal places. So what we need to know is what trig function we have to use here. So we have a given angle of 53 degrees. We can see that the 25 is opposite our 53 degrees, right? It's not touching it. It's not the adjacent side. And our x is opposite our right angle, so that's the longest side. That's our hypotenuse. So we're dealing with opposite over hypotenuse, so we're going to use sine. So I get sine of my angle, so sine of 53 degrees equals opposite 25 over hypotenuse. Now you got to be careful when you're typing this into your calculator, because since they gave us 53 degrees, your calculator has to be in degree mode. Okay, so now we're dealing with degrees of triangles, and since they gave it to us in degrees, your calculator has to be in degree mode. So before I go ahead and show you how to do it on the calculator, I'm sure we've done it before, but just to refresh our memory, let's go ahead and solve for x, so we can just plug this all in and come out with our value for that hypotenuse. So I'm going to prove to you that we can just switch this sine of 53 with this x. We can just flip them, and then it should end up being x equals 25 divided by sine of 53. And to do that, we would multiply both sides by x. Right? These ones will cancel. We'd be left with x sine 53 degrees, and then divide by sine 53 degrees. So that'll help us. We're going to have lots of problems like this coming up in this chapter where we're going to have a variable on the denominator. So you can just switch those real easy, and then you don't have to go through the extra steps. So x is equal to 25 divided by sine of 53 degrees. And I'll go ahead and do that real quick on the calculator. So on the calculator, make sure you do go to degree mode. And then second quit to get back to your home screen. And then just do 25 divided by sine of 53. And we get 31.30. So that length of the hypotenuse is 31.30. That gives us our hypotenuse. Next, they want us to sketch the triangle given that the secant of theta, or whatever trig function they may give us, is equal to 7/2. So I'm going to go ahead and always start by drawing my triangle. Right, standard form triangle, first quadrant, everything's positive. So secant of theta, we don't know what theta is, but we don't care. And secant is equal to 1 over cosine of theta. So that just means I can flip my secant, and that'll give me my cosine of theta is equal to 2/7. Since cosine is equal to adjacent over hypotenuse, I know that this adjacent side must be 2, and my hypotenuse must be 7. If you go ahead and do the Pythagorean theorem, you get a value of 3 radical 5 after you simplify it. So you go ahead and do the Pythagorean theorem, 2 squared real quick, plus whatever this side might be, x squared equals 7 squared. So that gives me 4 plus x squared equals 49. So x squared equals 45. And the square root of 45. 9 goes into 45, so 9 is the perfect square. So I get x equals square root 9 times square root 5. And we know the square root of 9 is 3. So my side equals 3 radical 5. And now I can take that and find the other remaining trigonometric functions. So I already have secant, I already have cosine, so sine of theta is opposite over hypotenuse, so that's 3 radical 5 over 7. Then I have cosecant theta, which cosecant is just sine flipped over, so that's 7 over 3 radical 5. Alright, I can't have a radical in the denominator, so I'm going to go ahead and multiply by radical 5 over radical 5. That gives me 7 radical 5 over 15 for my cosecant. Next, let's do, we already have secant, cosine, sine, and cosecant. Let's do tangent. So tangent is opposite over adjacent, so that's 3 radical 5 over 2. That's as far as we can go there. And then our last one, cotangent, is just tangent flipped over, so 2 over 3 radical 5. And again, multiply by radical 5 over radical 5 to get a value of 2 radical 5 over 15. So those are our 6 trig functions given the original secant. Finally, we have a laser beam directed toward the center of the moon, but as I aim my laser beam at the middle of the moon, it strays 0.5 degrees from the intended path. First thing they want us to do is how far has the beam diverged from its assigned target, right? So how far has it diverged from the middle of the moon? And they tell us that the distance from the Earth to the moon is 240,000 miles. So I'm always going to draw a picture and then fill in what I know. So I'm going to draw a picture with a very acute angle, right? And we know that this was 240,000 miles from the Earth to the moon, right? If I say this is the moon here, this is the Earth here. Not pretty, but it gets the job done. Right, so from Earth to the moon, it's 240,000 miles, but as I shot it at the moon, it's 0.5 degrees off. So this angle here is 0.5 degrees. I missed my mark by 0.5 degrees. They want to know how far off. Now, what's the distance of my actual ending compared to where I wanted to end, right in the middle of the moon. So my angle is down here at 0.5 degrees. So I have opposite and I have adjacent. So we're going to use tangent. So tan of 0.5 degrees equals opposite over adjacent. So to get that 240,000 out of the denominator, let's multiply both sides by 240,000. So 240,000 times the tangent of 0.5 gives me my distance, so however many miles I missed my center of the moon by. And if I go ahead and do this in my calculator, remember your calculator has to be in degree mode, because we talked about 0.5 degrees. And let's just make sure I'm still in degree mode. I am. So I do 240,000 times tangent of 0.5. And I get a value of 2,094.45 miles. So that distance, this distance here that I missed, was 2,094.45 miles. Okay, so that's the answer to part A. Part B says the radius of the moon is 1,000 miles. So the radius obviously being from the center to the edge. Will that beam strike the moon? Well, the radius is only 1,000 miles. Right, so if I'm looking at, I'm aiming here in the middle of the moon, the radius is 1,000, but we've just shown that I missed my mark by 2,000 miles. So after it's traveled this 240,000 miles, I missed the center of the moon by 2,000 miles. So since the radius is only 1,000 miles, I'm definitely going to miss the moon. So my beam is not going to hit the moon with that tiny difference of an angle. So will the radius of the moon, will the beam strike the moon? No, it will not. And you can give me a nice explanation why I missed the moon by 2,094 miles. Radius is only 1,000 miles, so I'd be shooting it off into space somewhere. Okay, so go ahead and try the example problems that accompany this in the PowerPoint. And just like before, I've included the answers at the end of the PowerPoint. So go ahead, check your answers with that, and then let me know if you have any questions in class tomorrow.